In today's lesson, Module 3, lesson number 4, we're going to be interpreting and representing patterns when multiplying by 10, 100, and 1000. And this is something we've actually been working on all year, but we're going to just kind of break it down a little bit differently. So let's take a look. If I had 3 ones on the place value chart, I'm just going to draw 3 ones. How many do we have? What's the value? Of course, the value is 3 ones. How many groups of 3 ones do you see? There's only one group of 3 ones. Right here, I'm going to circle my group. What if I want to multiply 3 ones by 10? Of course, it's going to move over on the place value chart. It's going to get one place value bigger, or 10 times bigger. And instead of 3 ones, now I would have 3 tens. Three ones times 10 equals 3 tens. So remember, we've talked over and over and over this year about when we multiply by 10, of course, it just makes our numbers move over one place value or get 10 times bigger. It shifts to the place value to the left. So what if I took these 3 tens and I wanted to multiply that times 10? 3 tens. If I multiply by 10, of course, then that would just shift over. And instead of 3 tens, now I have 3 hundreds. 3 tens times 10 equals 3 hundreds. We could do the same thing. We could take our 3 hundreds and we could multiply them times 10. And of course, then I would end up with 3 thousands. And we could go on and continue. We know that when we multiply by 10, that it moves over one place value to the left. But what if instead of multiplying by 10, what if I wanted to take my 3 ones that I originally started with, and I wanted to multiply those 3 ones times 100? What happens now? Of course, when we multiply by 100, we're multiplying by 10 and then times 10 again. It's going to move 2 places. So, of course, 3 times 100 is 300. 1 times 3 equals 3. And then these 2 zeros in the 100 tell me that I need to add 2 zeros at the end of my product. Okay, we could do the same thing. What if I wanted to do, go ahead and write that times 100. What if I wanted to take my 3 ones that I started with, 1, 2, 3, and I want to multiply them times 1,000. Now I'm going to shift 3 place values to the left, times 10, times 10, and times 10 again, and I will get 3,000. We could do the same thing with 4. What if I started with 4 ones? 1, 2, 3, 4 ones. If I want to multiply those 4 ones times 10, then 4 ones become 4 tens. If I take those 4 ones and I want to multiply them times 100, I could break 100 down into 10 times 10. 10 times 10 equals 100, correct? So that's really what we're doing. We're moving it over 10 times and then 10 times more. So that gets me my 2 place values. You may hear it referred to as 10 times twice, or 10 times and then 10 times bigger again. Okay. We could do the exact same thing if we wanted to multiply by 1,000. 1, 2, 3, there's 4 ones. And I want to multiply those 4 ones times 1,000. We could break 1,000 into 10 times 10. We said that made 100. If I multiply that times 10 again, that gets me 1,000. I'm getting 10 times bigger, 10 times bigger again, and 10 times bigger again. That moves me to my thousands place value. So all I'm doing is decomposing or breaking apart my 100 and my 1,000 into groups of 10. Okay, let's try that again. This time we're going to solve a little bit bigger number. We're going to do 15 times 10. Okay, so if I draw place value discs to represent 15, I would have 1 10 and 5 ones. Okay, look at that. Make sure you agree that that is 15. Now to represent 15 times 10, I would take my 110. It's going to get 10 times bigger, so it will become 100. These 5 ones get 10 times bigger. And so they become 5 tens. So now we can see that 15 times 10 equals 100 and 5 tens, or 150. 15 times 1 is 15. I have 1 0. Here's my 0 in the product. So what if I had this? What if I had 22 times 100? 22 times 100. Let's put that on the place value chart. I have 2 tens, have 2 ones, and I'm going to get 100 times bigger. We could break that 100 into 10 times 10 if we wanted to. I know that times 100 I'm going to move 2 place values. So 2 tens times 100 is going to equal 2 thousandths. My 2 ones times 100 will move to the hundreds place value. So I'm going to have 2 thousandths, 2 hundredths, 0 tens, and 0 ones. So my answer, the product to 22 times 100 is 2,200. 22 times 1 is 22. And we have 2 zeros to put at the end of our product. Okay, let's look at one more. What if I had 4 times 20? Just like we did 3 times 100, we said we could break that into 10 times 10, and that gets me the same value. What's another way that we could express 4 times 20? Look at what I've written. I said that 4 times 20 is equal to, or the same as, 4 times 2 times 10. Do you agree with that? Yeah, that's the same. 4 times 2 times 10 will give me the exact same thing as 4 times 20. So let's go ahead, let's represent 4 times 20 on our place value chart. So I've got 1, 2, 3, 4 ones. And they need to get 20 times bigger. Well, we know that the place value chart moves up and gets 10 times bigger each time that we move over on the chart. But I can make 2 groups of 4. Okay. So here is my 2 groups of 4 represented right here. Now I can take those 2 groups and make them 10 times bigger. And I have now 1, 2, 3, 4, 5, 6, 7, 8 tens and 0 ones. 4 times 2 equals 8. And I have 1 0 to go at the end of my product. So 4 times 20 equals 80. Let's try another one without the place value chart. Let's do 6 times 400. I could rewrite 6 times 400 as 6 times 4 times 100. I know that 6 times 4 is equal to 24. And I need to get 100 times bigger, which means I move 2 places on the place value chart, or I add 2 zeros at the end. So my answer is 2,400. Okay. What if we did 4 times 500? I could break it down into 4 times 5 times 100. 4 times 5, or 4 times 5 right here, is equal to 20. Now I need to get 100 times bigger, which is going to be 2 place values. My answer will be 2,000. I want you to take a look at this. Here in my original problem, I had 4 times 500. 500 has 2 zeros at the end, or 100 times bigger. But my product, 2,000, has 3 zeros at the end. Why do you think that is? It's because 4 times 5 equals 20. The product of 4 times 5 has a 0 at the end. That's 20. Then I still have to make 20 100 times bigger by adding 2 more zeros at the end. So the number, my final answer, the product, is 2,000. Let's take a look at your problem set. We're going to do a couple of these together. So if you need to grab your problem set, go ahead and do that. Problem set 3.4, or lesson 4 problem sets. If you have your Learn book with you at home, it's pages 21, the back is 22, and then page number 23. Okay, let's look at this together. Let's look at number 1. They've given you an example of 5 times 10. And of course, we know 5 times 10 equals 50. So they started out with 5 ones on the place value chart. And they made it 10 times bigger. So they're showing you that that equals 5 tens. So we're going to do number 1 together now. We have 5 times 100. So I'm going to put 5 ones. Five times 100 is the same as multiplying 5 times 10 and then times 10 again. So that's going to equal 500. 5 times 100 equals 500. 5 times 10 times 10 equals 500. Or if I wanted to write it in unit form, I have 5 discs here, and they are in the hundreds place value. So they're just showing you 3 different ways of representing or writing the exact same problem. Same thing on number 2. We start with 5 ones. It's getting 1,000 times bigger this time. So times 10, times 10 again, and times 10 one more time gets me to the thousands place value. So 5 times 1,000 is 5,000. 5 times 10 times 10 equals 5,000. Or if we write it in unit form, it's 5,000. They're just showing you different ways that you can break those numbers up and represent them the same way. And it represents the exact same number, it's just written a little bit differently. Okay, number 3 just asks you to fill in the blanks to answer the following equations. So sometimes you have your product missing, sometimes you have your factor missing, and I think you should be able to do those with no trouble. Let's go on to the next page. Okay, number 4 we'll do together. 12 times 10 asks you to draw place value discs and arrows to represent the product. So I'm going to start with 110, and 2 ones. I'm multiplying by 10, so my 10 will become 100, and my 2 ones will become 2 tens. So 12 times 10 equals 120. 110, 2 ones times 10 is 120. You'll do the same thing on number 5 and 6. All right, then this is a little bit different down here on number 7. So I want you 7, 8, 9, and 10. So let's look at what they've done here. Just like in our last examples. Okay, sorry for the interruption. Let's go back to number 7. So in number 7, we're decomposing, which just is a fancy word for breaking apart each multiple of 10, 100, or 1,000 before we multiply. So in number 7, your original problem says 3 times 40. So we can break 3 times 40 into 3 times 4 times 10. We know that 3 times 4 equals 12. So then we'll have to do 12 times 10. And 12 times 10 equals 120. Okay, number 8, you have 3 times 200. So this time we're going to break 200 apart into 2 times 100. 3 times 2 is 6. We still have to multiply by 100. 6 times 100 is 600. Okay. Next we have 4 times 4,000. So we'll do 4. We'll break 4,000 into 4 times 1,000. 4 times 4 is 16. We still need to multiply by 1,000. And 16 times 1,000 is 16,000. Number 10, 5 times 4,000. We'll do 5 times 4 times 1,000. 5 times 4 is 20. We still need to multiply by 1,000. 20 times 1,000 is 20,000.